Alright, let's get started. Today we're working on number 34, I think, of our LeetCode Grind 75, 169 questions. And today we're going to be working on number 283, move zeros. So, given an integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Okay. Note that to do this, Note that you must do this in place without making a copy of the array. Okay. Interesting. So let's toss in a comment block. I'm just gonna use the example, so 0, 1, 0, 3, 12. Let's try a naive solution where we swap one at a time with the nearest non-zero, or at least the solution that comes to me first, right? So the first operation would be swapping 1, 0, so something like that. Then it would be 1, 3, 0, 0, 12. Then 1, 3, 12, 0, 0. But this would be one scan. This would be... Oh, sorry. This would be one scan. This is just the start, right? This would be 2 scans, and this would be 2 scans as well. But potentially, if we have a situation where if we had, let's say, half of the array, so total 5 scans. If we had half the array as zeros in the beginning, and then the rest of them are non-zeros, then we could run into a situation where we don't if we had first half zeros and second half non-zeros, this would repeat a scan of a lot of zeros. So for example, we had like a 0, 0, 1, 3, 12. And so the first swap would be this, which would be 2 scans, right? Because this one and then here. And then it would be 1, 3, 0, 0, 12. And here again, it would be 2 scans. And then finally would be 1, 3, 12, 0, 0. In this case, it would also be 2 scans, right? And so effectively, we're rescanning portions of the array that we already know are occupied by zeros, because we're swapping the 0 to that part, right? So one possible solution is to maybe keep a reference to the next index to check for a non-zero number. So here, let's say that if we did this again, so rather than doing so here we would still do 2 scans, and we'll say next is equal to let's see, 0, 1, 2, 3, right? And here, and this would be the next index to check. And here next initializes at 0. So here now we do 0 scans, and next is equal to 4. And here we would also do 0 scans. And next is equal to 5. And once next is equal to 5, we know that we have checked all the non-zero numbers since we've hit the end of the array, and therefore we can return from there. I'm not quite sure what this exact sort of solution pattern is, but basically the idea is that we have this repeated work here. And I think this is like something from that I remember from cracking the coding interview. The idea of unnecessary work, repeat work, and something else. The idea is that once you have a naive brute force solution initially down, if you have no idea of the first initial sort of optimized solution, right? The first thing to tackle is, okay, we'll start with a naive solution. We'll start with what we think we have. And then we'll build on top of that and ask ourselves, where is the repeat work? Where is the unnecessary work? How can we get rid of it? So here we're trading a little bit of space, not quite linear space, but just constant space because we're just keeping a reference in exchange for our, in exchange for faster speed. Sorry, my mind blanked there for a second. So we'll just say if num's length is equal to 1, return, because there's nothing to do whether the first value is 0 or non-zero. And then we can say var next index starts at 0. For each indexed, because we're going to need to know which value or which index we're going for. And we're going to say for I in next index 2, num's length minus 1. Because this is inclusive. And we can say if next index is greater than or equal to num's length, return. Not sure if we can actually return from this for loop, but we'll see. We might have to do a return at like move zeros or something. We'll keep it basic for now. So for each value, if num's at I is not 0, then next index is equal to 0. Or sorry, next index is equal to I plus 1. And what if we do this instead? So rather than a for loop, we'll use a while loop. Next index is less than the length of our numbers. If it's a non-zero number, then we set our next index, and then we swap the numbers here. And we'll say val temp is equal to nums at, or equals to value. Nums at index is equal to nums at next index. So we just do some basic temp swapping. So we save a temporary store of the value. The current index that we're at, we take the number of the next index, which we're at right now. And then and actually we might be able to actually just get rid of this for loop entirely. Yeah, I think we can get rid of this for loop entirely. It's not necessary. Um, But then we lose our reference to where we're at. So maybe our var potential 0 index starts at 0 as well. So now we want to basically treat this as almost a for loop. So what we'll do is that we'll start our potential 0 index at 0. If we run across a non-zero number, we need to keep in mind that the first number might not be 0. Okay, so if we are at a non-zero number and a potential 0 index at nums is 0, then we swap the numbers. Else, so either the current number is a 0, in which case do nothing, or the number at potential 0 index 0, or is not 0. Okay, so there's a lot to think about here. So maybe actually we want to split this into a when case. Okay. So we need to keep track of where the earliest 0 is. Potential 0 index is not 0, and potential 0 index is less than num's length. And here, so move to next 0 or end of list. If potential 0 index is greater than or equal to the length of our array, we return. And then this makes it more complicated because we're dealing with a while loop rather than a for loop. I think I'm actually gonna jump back to using that for loop for now. There is an inefficiency there, and we can talk about it. But for now, I want to start with that, and then we'll see where we can go from there. So nums for each indexed index value. And we want to say if value is equal to 0. And we don't, because we just don't care if it's a non-zero. Then nums next index is not 0. Then we want to do the swap here. At index is equal to okay, so we swap around the values, and then the next index is I plus 1. Else next index is equal to I plus 1. Don't find suitable swap. Okay. Next index so so we found a suitable non-zero to still swap with. No more non-zeros to swap with. So we go through each one. If the value is 0, then we go through this block where we start by searching. We'll search until the next index either reaches the end or passes the end, or we find a non-zero number. If we find a non-zero number, we swap it and we set the next index to I plus 1. The problem is that var has found false, because this will still iterate. And maybe has swapped would be a better variable for it. We set has swapped is equal to true, so then we break out of here and we continue on. And basically we go through each index. We'll check if it's a non-zero, if it's a 0 or not. If it's a non-zero, then we don't care, right? Keep the order. If it is a 0, then we start at starting at next index. And we can say if next index is less than index, then next index is equal to index plus 1. So this is just in case we don't find a non-zero for a while. So then we just bring it up to speed and we check only the remaining numbers. Then we go through, we check to we find, basically this is just finding the first non-zero that we finding the first non-zero or finding the end. And if we find it, cool, we swap, and then we move on to the next number with this has swapped flag. Otherwise, we just return. And this goes on. This is technically inefficient because we don't want to do this each time, in the sense that there may be if the non-zeros are all, this is like the reverse case, where if we have half non-zeros, then other half zeros, this is inefficient because we don't need to iterate over the rest of the array when we already know that it's not a thing, that it doesn't hold non-zeros. But in theory this should work, unless this for loop is gonna screw with us. Right, size of the array, length is for strings. I does not exist, it should be next index, and technically we could replace this with the plus plus. Actually, no. What am I saying? This is our next index helps us out with that. One scan to hit, one swap. Next index is equal to 2. Then this would be one scan to hit 3, swap. Next index. So here, this is a 0. Our next index is at 0, 1, 2. This is 0, so we go to the next index. So this here, we swap with this. And then our next index is the next number, which is 4. And then this is another 1 scan to hit 12. Next index is equal to 5. So yeah, no, this is, we've already solved this issue with our next index. That was the entire point of our next index, is so that we don't run those additional scans in between to get our to avoid that repeat work that would place us in quadratic time. So in this case, at the most we would have to do, it would be half of the scans. We would have to iterate through the entire thing, but we would also have to iterate additional one scan each time, one additional scan each time, suppose that's the case. And we would have to do that n time, so that would still be linear time, because this additional scan, this additional this additional scan each sort of time we increment is only a doubling of our iterations, rather than something else, rather than something that grows with our runtime. So let's actually give this a submission, and let's see where we end up at. I could be completely wrong with this. This might be actually be still way too slow to be considered submission worthy. We'll see where we're at. Okay, so 71.41% speed and 27.81% space. I think that's actually perfectly reasonable, and I'm guessing that this is probably a close enough solution to what is completely optimal that we could roll with this. So this is where I'm actually going to end it here. So again, we use this next index pointer in order to avoid that sort of telescoping that would put us into a quadratic or I guess polynomial runtime in this case. I'm not sure exactly sure what kind of pattern this would fall under inside this sort of series, but it definitely is an interesting one. But in any case, I hope you learned something, and I'll see you for the next problem.